Hello everyone, my name is Mohammed Reza Homai. I'm gonna show you my software which can select optimum number of images from a dataset which collected by an UAV, and I named it UAV image selection, and we implemented this software for choosing the images which are so effective for creating 3D reconstruction. For example, we have a project, and there are some images in our project, and we want to actually remove redundant images from this project. At the first step, we import our images into Agisoft Photoscan, and my software is a complementary software for Agisoft Photoscan, and I implemented this software based on this version of the Agisoft, and currently the some some versions which named MetaShaped were released by. I implemented my software based on this version, and I will explain you why I implemented my software based on this version. At the first step, we need to align the photos, and we need to know about the exterior orientation of the photos. And after aligning, there are some photos, and we have some tie points in our project, and we want to choose, and we want to identify some redundant images which can't help us to create 3D reconstruction of our project, and we want to choose them and disable them from our project. And after disabling redundant images, our generation of 3D reconstruction is faster. After aligning photos, we make a triangulation of these tie points, and there are some triangles, and we use them for visibility analysis in our implemented software. After that, we need to export some values of this project and use them for selecting optimum image or disabling redundant images. Okay, we need to export these values, so all these parameters, and we can export this format of interior orientation of the camera from the Agisoft, and all of these values can be exported from the Agisoft, and we need to save exactly with this name in a folder. After that, camera has exterior orientation parameters omega phi kappa xyz for all images, and their rotation matrix. Ground control point means sometimes our project have some ground control points, and we can export them from the Agisoft XYZ of them. We can export XYZ of them from the Agisoft. It is the accuracy of the GCP, and we need to create this file on our own and use it file in my implemented software. GPS, sometimes we have GPS at the moment of the imaging, and we can export these values from the Agisoft and use these values. GCP sigma means the accuracy of the GPS sigma means the accuracy of the GPS, and since we don't have omega phi kappa, our accuracy is very bad, and our accuracy for XYZ is 10 meters, and our GPS could observe the XYZ by 10 meters accuracy. Another file is pixel errors. The average of the pixel error of image observation for each images, and they are for each images, and we sort them based on the image names. There is another file which contains the image observation for each point on each image, and we have these values for all points on all images, and we use them in our project for selecting optimum images. Another file is triangles and the coordinates of triangles and the relationship between triangles, and we can export this file from the Agisoft, and we can use them in our project and in our selecting optimum images project. Another file is tie complete. Tie complete means the coordinates of all tie points which were created by the Agisoft, and we can export this file from the Agisoft and use this file in our software. This is the coordinates of the each tie points and their color number and their normal. The last file is triangles, the coordinates of the all triangles, and we use these triangles for visibility analysis in our project. And after exporting these values, we need to import these values to our implemented software. At the first step in workflow, we import these data, and we need to choose the root of these data and use them for selecting optimum images. After importing these data, we can see the number of images, the number of tie points, and the number of observations. And after closing this window, we have a table here, and after clicking on each images, we can see the coordinates and their omega phi kappa, and after error propagation, we can see their accuracies. The second step is error propagation. Our selecting is based on error propagation, and we need to know the accuracy of each images in the space, and we need to know about their accuracy, and we choose optimum images based on their accuracy and based on their potential for creating 3D reconstruction of our model. And for this, we need to know about their accuracy. So we implemented an error propagation method to understand about their accuracy. After calculating of the accuracies, we can see average of the accuracy for all images, and we can see the average of the accuracy is correct. After closing this window, we need to go to visibility analysis step. In visibility analysis, we can understand which point can be observed by which images. For example, sometimes we have some occluded area, and we need to know about them. For example, in these images, sometimes these points can be observed, and we need to know about which point can be observed on which images. Because of that, we implemented an visibility analysis based on the triangles and triangulation. The next step is pre-analysis. In pre-analysis, we can understand how many images we can remove from our data sets, and we can understand about the maximum number of removed images and maximum increasing errors. Maximum increasing errors means after removing a maximum number of images, some errors would be increased in our 3D reconstruction, and these errors are something, some kind of prediction of our errors of the 3D reconstruction after removing this number of images. For example, in this project, we can remove 25 images, and after removing 25 images, the increasing errors is 12.4, and we can predict these numbers before creating our 3D reconstruction. After closing this window, we can understand about the increasing error and maximum number of error, and we can see the images which can be disabled from our project before creating 3D reconstruction. If we choose the root of the our project is here, and I choose the root of the project and choose our project, our Agisoft Photoscan project, and after selecting the project and closing it, we can see these this number of these images. We can see these images are selected. We can see some images were selected by our software, and after disabling these images, there is no we predict there wouldn't be any gap on our 3D reconstruction, and the increasing errors is 12.4. But sometimes we don't want to our increasing error would be more than, for example, 7%. After choosing 7, we can see the number of images we can disable, and we can choose the root of our project, and after closing and opening the project, we can see this number of images were selected for our project. It means after disabling these images, our 3D reconstruction wouldn't be our 3D reconstruction's error wouldn't be more than 7%. And we can use this software for selecting optimum images, and it can be very helpful for some project which we don't have enough time, and some project which we want to increase our speed of the 3D reconstruction. Thank you everyone for watching these videos. I put my codes in GitHub site and in my GitHub, and you can find my GitHub and find these codes by clicking to comment below, and use this implemented software for your project.